Stoichiometry test review. Coefficients represent the number of moles of each reactant. So when we balance our reaction for the first reaction here with 2, 2, and a 3, that means up here the moles represent 2 moles of the KClO3 produces 2 moles KCl, and 3 moles oxygen. Then the mole-to-mole ratio simply is the coefficient that's in front of the KCl. So go to KCl, there's a 2 there. So that 2 is the coefficient for there. And then in front of the oxygen, there's a 3 that balanced the reaction, so that coefficient is the number that goes there. So the actual ratio that you'll see it on the test would be written 2 to 3. So on the second one, you should have gotten it. That was a 3, 1, 3, and 2. For a mole ratio, that in front of calcium hydroxide was a 3, and in front of aluminum hydroxide was a 2. So the mole ratio there would be 3 to 2. In this next one, you should have had a 1, 2, 2, and a 1 to balance it. So that ratio would be 1 to 2, which would be written as 1 to 2. So letter B is what we're using coefficients for in our problems for stoichiometry. We want to change our compound from substance A to substance B. The only way we can do that is relate it with the mole-to-mole ratio. Question 3, you can underline what you're asked to solve for, put question marks. So that item you're asked to solve for should be substance B, whereas the item that has the number, unit, and compound should be your substance A item. So add up your formula mass and plug it in here in front of the grams for 3 calciums, 2 phosphorus, and 8 oxygens. That adds up to being 310.174 grams. That's equal to 1 moles of the same compound. And for room, I'm just going to write A up there because calcium phosphate is A. Next step, to convert to moles, since you're asked to solve for moles, this will be the last step you have to do. So you've got moles of substance A being the calcium phosphate. So in front of calcium phosphate, there's understood that there's a 1 there. So that's the 1 that goes there. And moles to substance B, which is your calcium. So in front of calcium was a 3. So that would go there. So multiply. Do your math. 60 divided by 310.174 times 3. You should get 0.58 moles as your answer in that question. Next question, what's the mole ratio between aluminum to aluminum oxide? So aluminum has a 4 in front of it, so 4. The aluminum oxide is this compound, so it has a 2 in front of it, so it's 4 to 2 is the ratio. How many moles of aluminum oxide are formed? So start with 6.25. That's a little big. So you're starting with 6.25 moles of oxygen. So that means moles of oxygen is to the bottom first. And you're asked to solve for how many moles of aluminum oxide. So you've got moles of aluminum oxide to the top. means you need the balanced equation coefficients. So in front of aluminum oxide was a 2. In front of the oxygen was a 3. So plug those in. And the answer you should get, multiply 6.25 times 2 divided by 3. You should be getting 4.17 moles of your aluminum oxide. What's the mole ratio of calcium carbide to water? So find calcium carbide. This reaction is balanced. There's a 1 understood to be there for calcium carbide. Then go to your water. There's a 2. So a 1 to 2 ratio. So you're beginning with 5 grams of calcium carbide. You need to solve for how many grams. So calcium carbide should be your substance A. Add up your formula mass of 1 calcium and 2 carbons for the bottom to 1 mole of calcium carbide to the top. So moles of your calcium carbide to moles of what you're asked to solve for, the C2H2. That means 1 mole of C2H2 would go down here, 2 grams of C2H2 on top. Add up 2 carbons and 2 hydrogens. Plug in those formula masses that you added up. So for the 1 carbon and 2, for 2 carbons and 1 calcium, you should have gotten 64.10 grams. Up here with the 2 carbons and 2 hydrogens, 26.038 grams. Go back to your balanced reaction. In front of the C2H2 was a 1. In front of the CaC2 was a 1 also. And then calculate for your answer. You should be getting 20.31 grams of your C2H2. So balance the next reaction. Since you've got 4 P's, you need 4 P's on this side. Then that's 4 times 3 to give you 12 on hydrogen. So you've got 2 hydrogen, so you've got to multiply 2 times 6 to get 12 hydrogens. And that's understood as a 1. What's the mole ratio of P to the pH3? In front of P is a 1. In front of the pH3 to balance it was a 4. So that ratio is 1 to 4. How many liters? So you're looking to solve for liters of the pH3 when you start with 4.2 liters of the hydrogen. 4.2 liters hydrogen gas times 22.4 liters of hydrogen gas is equivalent to 1 mole of hydrogen gas. Then that takes you into the mole step to convert it from hydrogen gas, substance A, to substance B of the pH3. In front of pH3 was a 4 to balance the reaction. In front of the H2 was a 6. Then the last step is converted out of moles of the pH3 to liters, being 22.4 liters of the pH3. You should get 2.80 liters of the pH3. So question 11 and 12, the reaction's already balanced for you. You asked to solve for how many liters of oxygen are produced when 6.54 grams of potassium chlorate breaks down. So 6.54 grams KClO3. The grams of KClO3 on the bottom add up that you have 1 potassium, 1 chlorine, 3 oxygens, and plug in the formula mass. That should be 122.548 grams and 1 mole of KClO3 on top. Then that means mole of KClO3 will be down here. 2 moles of oxygen gas that you're asked to solve for. Go back to the balanced equation. In front of oxygen gas is a 3 to balance it. So there are 3 moles of oxygen, and in front of KClO3 was a 2. So there's 2 moles of KClO3. So the next step would be 1 mole of oxygen down to the bottom. You're asked to solve for liters of oxygen, so that means you need to plug in 22.4 on top before you calculate. You should be getting 1.79 liters of oxygen as your answer. Question 12, you're looking to solve for how many moles? And you start with 3 moles of KClO3. So 3 moles KClO3. That means you've got to go to moles of KClO3 on bottom first and change it to moles of what you're asked to solve for of KCl. Go back to your balanced equation. In front of KCl was a 2. In front of KClO3 was a 2 also. So 3 times 2 divided by 2, your answer is going to be 3. And the last problem, you have 25.7 grams of NO2 to produce actually 21.4 grams of HNO3. So for your percent yield equation, you've got the 21.4 grams of HNO3 to put on top. You need the theoretical value of HNO3 to plug in on the bottom, times it by 100 to get your percent. But you don't have the theoretical number. So that means you've got to take back and use the 25.7 grams of NO2 and solve for the grams of NH3. No, excuse me. Not NH3. The grams of HNO3. Then plug that answer in as your theoretical value on the bottom.